Okay, so we are live now. Welcome everybody to the today's group study session. Let's start with the practice for OP. hmm Wait a second. What is this placement activity point? I'll look at it later on. All right, supplementary content, lecture slide in PPT. Right, week 3. एक बार ग्रुप में सब डाल दो ताकि जिसको ज्वाइन होना है वो ज्वाइन हो जाए. Let's just forget. I don't think now we will have any problem. Yes, now this is the speed we require. So I think you all know how to use select all clause, how to create Cartesian product, rename as operation. So you can rename a certain table using as clause into as. You can assign a variable a whole table. A variable would be holding the data of entire table. Now we have two subclauses in where and not. So it's simple and or statement, and meaning both of when both are true, then the result is true. When and in or when even one of them is true, all is true. Then we have string operations, course ID like this to check certain characters between the string. Let me increase the size. Yes, yes, better. Now if we go by, we have order by clause orders. It what do you say? It segregates. No, it I don't remember the word. Order में कर देता. It basically makes the table in a particular order. So we can make the order be ascending, or we can make the order descending. All right. Okay. Better. Yes. We can make the order ascending. We can make the order descending. I'm just quickly going through all of this. I'm not, explaining each and every one of this, so that we don't waste much time. Set operation. We can unite. Okay, let me see the order by. See, we ordered department name ascendingly, and total credits descendingly. So this is a random table. This and the data does not have a particular order. Now department name should be ordered ascendingly. So this is the department name. B comes before C, C comes before E, E comes before F, F, and so on, right? And so on. Now in that keeping in mind, let me remove this. Let's say we have a singular data set of computer science people, right? Once we do that, we have to keep in mind total credit should be in descending order. So in computer science, the total credit attribute is ordered in a descending way. Okay, we should quickly go through it. Set operation, select name, intersect. Okay, average operation, minimum operation. So what does average operation do? Takes out the capacity. Okay, so it takes out the average of the attribute capacity. Takes out the attribute of capacity. Once it has done that, it compares it. Okay, aggregate function minimum. So it will find the minimum of all. Then maximum, it will find maximum of all. So maximum of total credit. Okay. Then count. What does count do? Count function does is as course count. Let me highlight it. So what does count does is, let's say count course ID, right? Okay, so we have several course IDs. This yes, Ish and Fin history. Okay, all of these. And what are we doing? We are selecting the building attribute and counting it. Okay, so this is what it'll do. Two for bio. Is there two somewhere for bio? No, no. So what is this? Taylor is five. Taylor is five. So let's check. What's with Divya? It's she's coming and going. She's it's. I mean, I don't know what's the issue with. Okay, let's leave it. So Taylor once, Taylor twice, Taylor thrice, Taylor quarter, fifth. Okay, so fifth five times. Okay, so it will count the attribute that is coming out. Okay, it will count for the attribute that is coming out. Okay, okay, now it makes sense. Some some credits. So finance has three credits. Computer science has four four three 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 20. Sorry, 3 3 4 10 17 credits. Yes. Okay, so this is module summary. We have completed the module. Now week 3 also tells us it's about nested subqueries. Hmm? Set membership. So this is a where clause, and in that where clause we have a sub clause or a subquery. In that where clause there is a subquery. Okay. So while solving this, we have to solve the subquery first, and then reach to the outer layer. We have to solve the first subquery first, and then reach the outer layer. Okay. Let's remove all of this. Let's see the example. See what we are doing in the first question is, we are selecting distinct course IDs from the section table. We are seeing distinct course ID from this table section, where semester is fall, year is 2009, and course ID in. What does this clause mean? This much, right? We have to figure out this much. course ID and select course ID from section. So the course ID from section where spring and where the semester was of spring and year was 2010. Okay, 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 okay. So find the courses offered in fall 2009 and in spring 2010. Okay. So the first query would give all the courses available in spring sorry in fall 2009, and the sub query would give all the courses where the semester was spring and the year was 2010. It will be more clear once we start solving the questions. Select distinct t name. Select distinct t name from instructor as t, instructor as s, when t dot salary is greater than s dot salary, and s department is biology. So what this question does is find the name of instructors with salary greater than that of some or at least one instructor in the biology department. Okay, same query using some clause. Okay, so we could have written it in the simpler way, but this makes it more readable. Select name from instructor where salary is greater than some. Select salary. Okay, okay. This makes the similar table as this. However, it compares the salary of the prior table to the latter one. Okay. Define a, oh sorry, definition of some clause. Definition of some clause. F comp some R. Okay, okay, okay. Oh, this is definition thing. Set comparison all clause. It should compare with all of it, right? To find the name of instructor whose salary is greater than the salary of all instructor in biology department. Okay. Definition of all clause. Test for emptiness. Exits. Use of exist clause. Okay. Yet another way of specifying the query. Find all courses taught in both fall 2009 and spring 2010. Okay. So we would be selecting course ID. We would be selecting section, the main table, where the semester is fall in 2009, and from another table and exists, select star from section as t, semester spring and year 2010, where s dot course id equals to t dot course id, and not exists is just the opposite of the same. Unique clause constructs test if, whether a the unique construct tests whether a subquery has any duplicate tuple in its result or not. The unique construct evaluates it to true if a given subquery contains no duplicates. Okay, okay. So we can also write subqueries in the from clause while assigning which tables to be used. Okay. There's this with clause provides a way of defining temporary relation. Okay. Complex queries using with clause. Find all departments where total salary is greater than that of average. Okay. We can also put subqueries in select clause. modification, deletion, delete from instructor, delete all instructors, delete all instructor from finance, deletes all instructor from finance, delete all tuples in instructor relation for those instructor associated with a department located in Boston building. Okay. Deletion, as we delete tuples from deposit, the average salary changes. Okay. Insertion. Add a new tuple to the course, or equivalently insert into courses. Insert into course ID, title, department in credits, where values are CS, database, D.B.M.S, computer science, and 4. Okay. Insertion. All the instructor to the student relation with the tool credits set to 0. Okay. Update statement. Updates the salary, updates given attribute. Mhm. Set salary. Okay. Same query as before, but with case statement. Okay. So we can all say this na कि they, the way they have completed or just compressed all of this data into a single week, it's just bad, right? They shouldn't have compressed all of this data, because this is some important shit. So let's go with join relation. Join operation takes two relation and returns a result, and return as a result another relation. A join operation is the Cartesian product which requires that tuple in two relation matches. It also specifies that it also specified the attributes that are present in the result of join. Okay. Types of join. So there are cross join, inner join, equi join, natural join, outer join, left join, right join, full join, or self join. So you would have to go through all of these joins. Let me ask someone: Is will someone like to take over? Anjali, Asadullah, will someone like to explain all the types of join?
Hi, actually, I'm in office and I cannot actively take part in discussion. I'm just
Okay.
listening. You can please explain.
So okay. So just tell me one thing. Have you
Mhm.
completed week 2?
Yeah, I've completed week two. I'm just wanted to understand the uh, SQL queries in week three.
Okay, so yes, we will be doing week 3 right now. Just
Mm.
I think it will take another 15-20 minutes to cover all the slides. That's it, and then
Not
we'll
an
start.
issue. Mm.
Then we'll start coding.
Not an issue.
Okay, I think I have all the questions here. All right, give me a few seconds. Okay, Anjali, would you like to take over? What a blunt no! You could at least open your mic. Okay. So let's go with cross join. Cross join returns Cartesian product of rows from table in the join. Explicit select star from let's understand. Cross join returns the Cartesian product of the rows. Just wait. Welcome Deepak. Welcome Deepak. Okay, so let's continue. Cross join returns the Cartesian product of rows from tables in the join. Product of rows from table in the join. Let's see. Have they not provided? relation course, relation prereq. Observe that prereq information is missing for C31 and course information is missing for CS 347, right? CS 347, we don't have course information, and at the same time for prereq, uh, prerequisite is missing for 315. Okay, course inner join is specified as natural, the second course field is skipped. Okay, so what inner join does is bio 301 bio and CS 190. Okay, so what inner join does is, inner join would do is, let me just scroll it through and done. So see, it takes the table, it takes both the tables. Okay, let me remove it and do it a bit clearly. See, it takes both the tables and finds out all the tuples that are not common. So these are the tuples that are not common. All right. So they will the function will by default remove it. Okay, the tuples that are not common, and this table does not have prereq id, and this table does not have title and department name. All right. So while performing natural join, what it basically will do is merge all of this, merge all the attributes. Once all the attributes are merged, they mhm, okay, they print out all the tuples right here. Okay, the tuples that are common in both the tables. That's what inner join is. The data that is not provided, that is not complete. Let's say, as they say that CS 315 does not have a prereq id, right? They do not have a prereq id, so it will not be provided in the solution. And same is the case with CS 34 this 347. It does not have title, department name and credits. Okay, so it will not be in the final that final table. The natural join is pretty simple. Wait a second, what inspired by a natural, the second course idea is skipped. What are they doing? Outer join. What is an outer join? An extension of join operation that avoids loss of information. Computes the join and then adds the tuple from one relation that does not match tuple in the other relation. Okay. Uses null values. Okay. So see this Venn diagram carefully. Left natural join. It basically covers all the data from the left side of the Venn diagram. Alright. From the left side of the Venn diagram. Now that meaning, let's say this was A and this was B. So the data on the left, that is in A, should be covered in its entirety. Okay, along with the data common between these two. So what this does is this takes all the data that is present in it and puts it right here. All right. Now there are some common elements between them, right? This much part that belongs to B, but is still covered in the black portion. We have this bio 301 common and CS10 this 190 common. It takes the data that is common and the extra attribute between them and puts it right here, keeps it in the final table. All right, I hope you understand. Let's move forward. And same is the case with this B join, this right outer join, natural right outer join. Okay, it takes all the data present here and the common data present here, merges them, and provides us with the solution. All right, let's move forward. Joint relation, joint operations take two. Okay, blah blah blah. Full outer join. So basically, what this does is take this entire table, take this entire table, merge them anyway, and just return the table. Wherever the data is lacking, wherever the data is not present, it basically just assigns null value. It basically assigns null value. Okay. View definition. View is defined using the create view statement, which has the following: create view v as query expression. Okay, the view name is represented by v. Can someone explain what view does? I have uh, I have less mastery over this view. Deepak, Deepak, hello. Okay, no worries. Then I would think I will have to do it on my own. Let me just check. Okay, so last two slides are not important for OP. And before I move forward, do subscribe to my channel. Do subscribe to my YouTube channel. It's simply Suchit Sharma, and we are live here. Yay! What's the issue today? It's simply Suchit Sharma, and have a particular order. And the first question is to find the name of instructor who's 0. Okay, so the final part, view part. Can someone explain this? I have a bit confusion in this. Can someone explain this one? Okay. Done, done, done. Okay. So, in some cases, it is not desirable for all users to see the entire logical model. Consider a person who needs to know instructor name and department, but not the salary. This person should see a relation described in SQL by this select ID name department name. A view provides a mechanism to hide certain data from the view of certain users. Okay. Once view is defined, the view name can be changed to be used to refer to virtual relation that the view generates. The view definition is not the same as creating a new relation by evaluating the query expression. Rather, a view definition causes the saving of expression. Okay, okay, let's understand it now. Hmm. 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 Okay. Create view faculty as select this. Okay, from instructor. Select name from faculty where view of instructor without the salary. Okay, okay, okay. So this will create view faculty as select this. Okay, oh, now it makes sense. Create view department total salary as okay, okay. Department total salary, department name, salary. Okay, okay. Welcome Chhatrapal.
Hello.
Welcome to the session. Have you completed week 2?
Yeah, yeah, yeah.
Okay. So let's start right here. Alright. We're finally starting.
By the way, what all are we going to cover today here?
See, can someone just write it? Anjali, please write it in chat box. I have to start. So it's basically these 5 questions, and if time allows, we would be proceeding to supplementary contents. Sorry, this OPSQL questions that they have given us. So let's start. Write a SQL statement to find the name of team that have played more than 3 matches. A SQL statement to find the name of teams that have played more than 3 matches. So the keywords that we are provided. Okay, black pen, black pen. We have the following keywords. Find the names of teams that have played more than 3 matches. More than 3 matches should be there, not just more than 3 matches. Right? We have three keywords. So let's check names, teams, and matches. So team, team name, matches. Okay, name, team, and matches. Team ID, host ID, guest ID. Okay. Just give me 1 second. Hmm. So let's start coding, right? Immediately always write our favorite select from where clause. Okay. And what are they saying? Name of teams, right? So we have to select from teams, right? Increase the size from teams. Let's call it T. We can write teams as T, or we can simply write T. What did just happen? Okay, so it backspace does do that sometimes. Hmm. Now we have to connect the matches data and the team data, right? The matches data and the team data. This table and this table. So it is connected. These two tables are basically connected by host ID, guest ID, and team ID, right? So we can perform join on this. We can perform join on this. Let's perform a join. Join join matches. We have to join matches table with team table. So we write join matches first. Join matches. Let's call it M on. It's better to write as M. Teams as T. We are joining matches as M on. Is it clear enough for you guys?
Yes, yes.
So we are joining these on T. Let me see. T dot something, right? T dot team ID. T dot team underscore ID, which should be equals to M dot team ID should be equal. Okay, so basically, uh, the team ID should be either equal to this host ID or the guest ID, right? We have to perform join on this. This brings out the common between them. M dot host team ID, and there's this big or. Let me also do this. T dot this team ID should be equals to M dot. No. It was not host. It was guest. Guest ID. Guest team ID. We can then group them. Let's group them. Group by T dot name, the name of the team. We are grouping them by the name of team. Uh, having having count, I guess count of m dot match num be greater than 3. Let's see if it works. It does not work. What is the problem? Wrong attribute set, not a select statement. Okay, so we have not yet provided the select statement, right? What do you think should we put in select statement? T dot name, right? This takes too long. Yes, it is 100 on 100. So this code work. This code works. Okay, let's ask GPT to explain this join part. Okay, so join matches. This line indicates that you are performing a join operation between teams and the matches. Let's ask why did we join tables, right? Why did we join the two tables? It is important for extracting crucial information about teams that have participated in the matches. By joining these table using the team ID from teams and table, host team ID and or guest team ID from the matches, the query aims to find teams that have participated in matches either as host or as guest. Okay, aggregating association of team with matches. The team table likely contains information about the different teams, such as their names, okay, such as the name, ID, possibly other details. Meanwhile, the matches table probably includes the data over various matches. The aggregating team participation once joined the query groups the result by team name. This grouping helps in summarizing the matches, allowing further analysis such as counting the number of matches. Okay. Now I'm getting some idea. We are slowly and steadily understanding this part. So, Anjali, Divya, are you guys have you guys started to understand what this join and group by statement did?
Actually, I joined now. I'll pick up later. I'll see. I'll check this.
Okay. What about Anjali?
I understood the joint statement but not group by.
Yes. Now let me explain this once. Okay, give me 1 second. Yes.
Excuse me, I wanted to ask, yeah, in the resource they given, no, like university data and all, how to access that in PG admin?
Just wait a second. The resources that they have provided is right here.
Yeah. So after that, what you have to do? We have to download that first.
What do you, matlab, why do you need resources for?
Like in PG admin for practice, how we are practicing that data set, not this. Yeah, these questions they given, no? So how to practice these questions?
I don't have the idea currently. Wait a second. Wait a second. Uh, just 1 second. Huh? We don't know how. Let's read instructions. Right. Can we do it later on, please?
Yeah, okay, it's okay.
Because I
Yeah,
want to do it. Even you just
okay.
told me something new. Even I am now interested in doing
Oh,
this.
it's okay.
Yes,
Can do
but
it later.
yes,
End of
we
the
need
session.
to finish this 5 questions first. Right.
Okay.
So let me tell you what these this much part of the code means. Okay, where is it? Week 3. Week 3 question 1, right? So what we are doing here is we are merging these two tables now. We are merging these two tables. Once we merge these two tables, how are we merging it? We are merging the matches, right? So the matches table contains the data about host team and guest team, and when we merge it with the original team ID, we get to know the name of teams who have participated in the match, right? So let me tell you like this. If this was our data set, let's say if this much was our data set, and somewhere around here we had this, and let's say in this we had host team ID, we had guest team ID, we had match date, we had guest team score, and host team score and all that. So this data may have the name of host team. Let's say it was Royal Challenges Bangalore, and this one having Chennai Super Kings. All right. Then this tuple would have, this attribute would further have, let's say, name of Chennai Super Kings, and this side we have Rajasthan Royals. Right. What this finally does is, this merges all of this data into a singular table, into a single table containing just the name. So let's say we have RCB, then we have CSK, then we have Delhi Daredevils, then again CSK, then just the name of the list randomly ordered. Finally, when we go to this, let me show you. When we moved on to this part, group by, it groups the data set over the name. So let's say CSK tuple was spread across the attribute. Let's say this was our table and CSK was here, then somewhere here, then here. What it would do, it would basically merge it all into a single one. All right. Once it merges this scattered CSK data set into single one, we just have to proceed with single line, that is having count, counting the CSK one, they should count greater than 3. That's it. That's it. I think this was an eye opener question, and from now it would be easy for us to continue with the questions. So we have write a SQL statement to find the first name, the last name of faculty of department, having department code as Masters of Engineering, who have issued at least one book, such that there are no duplicates, first name last name pairs. Right. So how much we have? We have one, we have second, we have third, we have fourth, we have fifth, and we have sixth. We are provided with 6 pointers for the question. So let's start one by one. Faculty of department, right? Okay. I think I would have to, decrease the size of pages. Alright, now we can accommodate all of this. This still remains the same. Right, this is better. So we can move back and forth with this. Alright. So we have to write a SQL statement. So first name, last name of faculty. The first name and last name of faculty is provided in this table. In this table, and then department code as ME. Department code as ME. These two tables, they are connected by department code. Okay. Who have at least issued one book. Issued one book. Book. Book issue, right? So we have to connect book issue. Book issue is connected through members table by member number, member number is connected. Okay, so this is just a Maya Jal, right? This key connects to this. This connects to this. By reaching here, we can reach the faculty. Through faculty, we can reach department code, and we have to keep in mind these three tables: one, two, uh, actually four tables. These four tables, right? One, two, three, and four. Right. So this is how our brain should work. No duplicate. Last name and first name pair. We have to connect this data, this data, this data, and this data. Let me remove this. So let me close the door. Let's start with. So since we need no duplicates, I think we would be using distinct here. But anyhow, let's start. Select. Let's write our basic clause. Select from. This week focuses on join, where. All right. So let's start from. We are using the faculty. We're using the faculty as F. We are starting with this table. Then we also need to join, I guess, 2 to 3 tables. This, and this. Joining book issue on I guess member number के through कर सकते हैं. Join book issue on member dot member number. Should be equal to b dot member number. We are joining these two into one table. Once we join these two into a singular table, we see that we also have to connect this through ID now. Let's check. We have to connect these two table to faculty. I think we can join. Now we can also do another. Let's do another join. Join. So what we just did is we joined these two tables, and once we join these two table into singular table, we are joining this to the third table. All right.
Then from instead of faculty, there should be member, right?
Sorry.
In the from clause. You have to write instead of faculty members, right? Because you written members dot members number, right?
No, no, no. Let me correct this. Join. Let me. I still don't understand what are you saying. Excuse me.
So here from faculty, if you written, no, then join on should be faculty dot.
No, no, no. I am joining it now. So first what I did was I joined these two tables. Okay, I joined these two tables into a singular table, right?
Okay.
We joined this into a singular table. Let's say, let's call that table X. Let's
Yeah,
call
I'm,
that
I'm
table X.
asking like you have to mention book issue and members, right?
Yes.
But you
Uh,
didn't mention it, right? That's why I'm telling.
no, I'm telling. I'm going to it. I'm reaching there. Now to this X, I am merging it with this table, right? Now
Yes,
this
that
new
I
table
understood.
formed. I am joining it with the faculty table. Now what? Back to what you're saying. You're saying that B dot member number, right? Now this much.
Yeah, that is correct. The book that is B means book issue, but member dot member number is there. No, I'm asking like from faculty instead of that there should be from members join book issue. It should be like that, right?
No, the thing is, see, these we have to reach from faculty. We have to reach from faculty till here, right? Hannah,
Yeah.
we have to reach here. But there is no direct connection between these two. There is no common attribute, right?
Okay.
So to reach there, we are using this member table because it has a common ID. Sorry, a common attribute with faculty. So we can join it here like this. All right. And from once we reach member, we can also reach book issue. All right, because they have this common attribute member number. So I am basically using this transitivity property. I am reaching from here to this table to this table, and from this table to this table, and vice versa, meaning coming from here to here and then here to here. Did you
Okay.
get it?
Yeah, I lost somewhere here. It's okay. I'll figure out it later.
Okay, because
We have network issue is there, so
so basically, I first initially performed a join on this book issue, and members. All right, and
okay.
from the new table that is formed, I am joining it with this members as M on what are the common attribute. Okay, ID is common attribute. So M dot ID should be equals to F dot ID. F dot ID. Once that happens, we move into where clause, where the member number, where is the B dot member number. Okay, member NO, not this full member NO, member number. And in fact, to use this as M, I have to write it before this, where B dot member number equals to M dot member number. So we made a table uniting these two, then we are removing all the tuples that are not common, that are not equal. Initially, while joining these two, these this would have performed a Cartesian join, but we are performing a natural join now. I'm stuck a bit here. Don't think this is how. Let's remove this line for now. What are we selecting? We are selecting faculty F name and faculty S name, right? So this works. Distinct. F dot faculty name, faculty underscore F name, comma it is capital F, right? And F dot faculty underscore L name, where F dot department code. So let's join these two. Department department code should be equals to ME and exists this subquery. Select one book issue, where M dot member number should be equal to M dot member number should be equal to P dot member number. All right. Select distinct faculty first name, faculty last name. From faculty as F, joining members as M on same ID, joining book issue as B on member number. Mhm. But I guess this should be just like this. Should just cover M. Let's see. So there's wrong somewhere. B dot NP does not exist. Line 4. Member number. That's a typo. Okay, so this passed, right? Let's ask GPT to explain this much better. It will explain it much better than me. Has does anyone has any idea how to exit it? Okay, better.
Can you explain the last line?
Yes, yes, yes. So what we just did was this much now, where the department name. So this is the basic. This was provided in the question now. See this, where department code is ME. So F dot department code is Masters of Engineering, and there exists, select one from book issue where member number is okay, who have at least, who have issued at least one book, right? So we are is select exists mean there exists someone having a singular tuple in book issue where member number is equals to this members dot member number, right?
Here, select one means it will select everything. Is it like a star?
No. Select one means a singular tuple. Okay, select one tuple. Okay, so if you can select a single tuple from this table that is formed from the subquery, and it exists, right? If you cannot even select a single tuple, right? Let's say the table returns 0 or null value for this subquery, so the exists would return false, right? If this is
No, I
false,
didn't understand.
sorry,
I didn't understand. One means here it's selecting only one row.
yes, one tuple.
Okay.
Let me make you understand. So let's say it was 3, instead of 1 it was 3, and let's say this was our table, so we can select one tuple, second tuple, and third tuple, right?
Okay.
You are selecting three different tuples. Once you are selected these three different tuples, this would
Actually,
return a,
this is not tuple. Is it tuple? Department code, department, that is an attribute, right?
yes. Oh, yes, my mistake, that, oh, I meant attribute, but my lips were saying tuples. Okay, sorry. Select one from book issue where member number is equals to m dot member number. Let's
I think
see.
is it like a star? Is it like a star means it will select all the tuples, right?
Yes.
Like same.
No, I don't think that is same. Read this. I'm saying the same thing, but I'm not much clear in my vocabulary, so that's why you're not understanding. Understood?
Okay.
Select distinct faculty. This line selects a distinct combination of faculties, first name and last name. The distinct ensures that only unique combinations are allowed. From the faculty as F specifies the faculty table and assigns it as alias F to use in the query. The alias F simplifies the referencing faculty table throughout the query. Join members as M on, MID, and FID. Okay, okay. Guys, what do you say we put a rest to this? Okay, I make the video and you watch it online. All right. I just watch the time. I have to leave for some important stuff.